So, as I was saying, this is a very tricky topic, and I'll try to do my best to explain how I think about it and how I reason it out in my head so that it makes sense. But it may take multiple tries and multiple videos and just keep thinking about it, and eventually you'll get it, okay? But it's not easy. Not easy stuff. So we already did calculating pH of weak acids using Ka statements. Kb statements work pretty much the same way, right? Now we're going to be talking about acid-base properties of salts. Now you'll hear it a couple different ways. So you'll see like acidic salts or basic salts, or they might talk about salt hydrolysis. Hydrolysis, so hydro is water, lysis is breaking apart, right? Anytime you hear lysis at the end of a word, it refers to breaking something apart, right? So a lot of times in science we use what's it called? Prefixes and suffixes to represent certain things, right? Like you think hyper, hypo, hetero, homo, all those different prefixes, and then suffixes like lysis and ace, right? Like ace is an enzyme, right? If you're ace at the end, it's an enzyme. So different things like that. And this here, we have hydrolysis, breaking apart of water. So basically what's happening here is a salt is reacting with water to produce a solution that is now either acidic or basic. Okay. Not all salts are acidic or basic. Some are neutral. Okay. Neutral salts are formed from the cation of a strong base reacting with the anion of a strong acid. So for example here, like NaNO3. Okay, think about which two bases reacted to form those two things. I'm actually going to switch to this because I'm going to want to write on this. I have it open. I know I have it open. There it is. It's hiding from me. So if we think about this, what acid form or what base? So we have Na plus OH minus gives us NaOH, right? And this is a strong base. Okay, so if we put Na in solution, Na in water, none of this is going to form. Right? Because strong bases will always totally 100% dissociate. Okay, so if we put Na in water, this reaction will not happen. Okay, if we put NO3 in water, it's going to react with H plus to give us HNO3. And in this case, this is a strong acid. That means none of this is going to form. Sorry, none of this will form. None of that will form. So when we put this salt in water, when we put NaNO3 in water, it will just stay Na plus NO3 minus in water. It'll just stay that way. No acid base will form. It's going to be totally 100% neutral. Does that make sense? Neutral salts. Okay. the anion and cation will not form, the anion and cation both form strong acid, strong base, or they're the anion or cation of a strong acid or a strong base. Basically just add H to see if it's a strong acid, add OH minus to see if it's a strong base. If they're both, then it's going to be neutral. Now, if we have basic salts, so here, and I actually don't even really like the way this is necessarily worded right here. So we have K plus, oops. So this is going to break apart into K plus and C2H3O2 minus, right, in water. Okay. Regardless of the solubility, we're not going to worry about the solubility of this salt right now. It is a soluble salt. Okay, it is soluble. And most of the time, they're going to give you something that's soluble and ask you, is it acidic or basic or neutral? Okay. Do be aware, though, if they give you an insoluble salt, then it's not going to be anything, right? It's just not soluble, so it's neutral then, I guess. Then think about how will this react? How will these two react with water? And this is why I said before I like to write my water with HOH plus HOH. So how will these react with water? Well, the K plus will take on OH, right? A plus always takes on the negative. So it's going to be KOH plus H plus. Now KOH, this is a strong base. This is a strong base. So none of this will form. None will form. If none of this will form, then none of this will form. Okay. So none of this forms, none of that will form. So we won't have no acid, we'll have no acid in solution. Okay, none of that will form. It's a strong base. The strong base would totally dissociate into K plus and H2O. Right? That K plus is not going to take on OH minus to form KOH. The other one, this C2H3O2 minus, it's going to react with the H plus and form HC2H3O2 and OH minus. So this is acetic acid. It's not one of the 8 strong acids we talked about, right? So if you memorize all the strong acids, you'll know that anything that's not a strong acid is a weak acid. So this one here is a weak acid. So this will form. Okay? So if this is going to form, some of this is going to react with water to form this, what is also going to be in solution? This is also going to be in solution. So as this reacts with the water, we're going to be producing OH minus ions. So what kind of salt would this be, acidic or basic? Would this be basic or acidic? If we form OH minus ions in water now, does that make the solution basic or acidic? Well, it makes it basic. So if a weak acid forms, we get a basic solution. Okay. One of the tricks, though, is to think if you have a strong base formed and a weak acid formed, the solution is going to be basic. So strong indicates what type of solution you're going to have. It's going to work the same way with acid solutions as well. Okay, so let's look at an acid. We already know this is acidic, but whatever's. So we have NH4 plus here. We have NH4 and Cl, so we have NH4 plus and Cl minus. Again, going to react with HOH or water. I just like writing HOH. HOH. These are hypothetical, so that's why I wrote the equilibrium expression. One of them is not going to work. I'm not sure which one yet. Or I guess neither of them could work, right? Or they both could work, and we have to figure out which one's the stronger, weak base or weak acid. We're not going to do that, though. Don't worry about that. Anyway, so NH4 plus, HOH, Cl minus, HOH. So NH4 plus, a little bit tricky here, right? This one is actually going to give up its H plus here, and we're going to get NH3 plus H3O plus. That one's a little bit tricky. So that one, this one acted as the acid, this as the base, this is the conjugate base and conjugate acid. Okay, and NH3 is a weak base. It's not it's not an OH at the end, so it's not a strong base. So this will form in solution. So this will form. Okay, this one Cl minus will react with HOH. You'll have HCl plus OH minus. So this is a strong base, strong acid. Sorry, strong acid. Duh. So this will not form. So this reaction will not happen. We won't get any OH minus in solution. Okay. Now because this NH3 will form, so will this. Since this forms, we're going to have an acidic solution. Again, we saw we had a strong acid produced from one of the ions, so we get a acidic solution. So it's not really that this one's producing a strong acid, it's really that this one's producing a weak base. So we're removing some of this acid and creating a acidic solution. Or this is acting as an acid, I should say. This is acting as an acid, creating an acidic solution. Okay. All right, your turn. Well, actually, not your turn yet. So here's kind of a instructions on how to do this. So if both cation and anion contribute to the pH situation, compare the Ka to Kb. So this is if like I said here, if both cation and anion, if they both formed weak bases, or sorry, if this one formed a weak base and this one formed a weak acid, okay, then you'd have to determine which one. You'd have to determine which Ka is the Ka larger or the Kb larger. Okay, if the Ka is larger, it's kind of opposite. Okay. So if Ka is larger, it's acidic. If Kb is larger, than basic. But let's not worry about that right now. Let's look at this. So just look at these instructions here. So look at the salt and ask yourself which acid and which base react to form it. Ask yourself strong or weak for each. Embrace the fact that strong wins. So as I said here, if you form a strong acid, then the solution will be acidic. If you form a strong base, then the solution will be basic. Okay. If you predict basic, write OH minus. If you predict acidic, write H plus. Whatever one is the strong is the spectator ion. Write water is HOH, like I said, to make it easier to show hydroxide and hydrogen ion was formed. Okay? Okay, so if we look at this one, which is the quantitative pH of FeNO3? So this one, we have Fe plus 3, NO3 minus 1, right? We're going to add HOH, we get HNO3 plus OH minus, and here we get FeOH. I don't really care about balancing it, plus H plus. Doesn't really matter if it's balanced right now. Okay, so this is a strong acid. This is a weak base. So therefore, this will form. If this forms, we get H plus in solution, making the solution acidic. So we'll have this reaction down here. Okay, take a second, try these ones. Tell me, acidic, basic, or neutral? And show the appropriate equations. Okay, we good? Okay, first one, I think we actually did this one already, but that's okay. Na plus HOH yields NaOH plus H plus. This is a strong base. C2H3O2 minus plus HOH gives us HC2H3O2 plus OH minus. This is a weak acid. So this will form. So we'll go OH minus. So this is going to be basic. Okay, and also this is a strong base. So that's how we know it's also basic. Next one, again, I think we did this one too, NH4 plus and NO3 minus. The first one we get NH3 plus H3O plus. This one's always a tricky one, right? That's a tricky one. This is a weak base. And this one's HNO3 plus OH minus. This is a strong acid. So this one will form. So we'll have an acidic solution. And just remember, strong acid means acidic. Okay, and then the last one, Al2SO43. Oh, why did I write the whole thing? So again, I don't really worry too much about balancing these at the moment. So Al, come on. Uh-oh. Oh. So Al3 plus HOH. We're going to get AlOH3 plus H plus. This is a weak base. And then we have SO4 2 minus plus HOH. And we're going to get H2 SO4 plus OH minus. This is a strong acid. So this one will form, that one will not form. So we'll get H plus, so this will be acidic. Okay? All right, now let's look at it in terms of Ka and Kb. One of the tricky things here is that these salts like SO4, like Al2SO4 and AlOH3, like these things don't necessarily have Kas and Kbs a lot of times. Usually you have to look at the conjugate of them. But there is a relationship between Ka and Kb. Okay, so the relationship between Ka and Kb is really, really simple. It's this. This is what you really need to know right here. Ka times Kb equals Kw. I showed the work here on how to do it, just so like if it helps you figure out, like if it helps your brain kind of make sense of everything a little bit better. you can figure that out. Oh, period's over. So let's stop there. We'll continue on Thursday and we'll talk about this. Sorry, I lost track of time there. Yeah, sorry about that. Anyway, so we'll stop there, and don't worry about the homework. We'll just work on the lab, and we'll do the rest of this on Thursday, and the homework will be for Thursday. Okay, so do the lab. Worry about the lab tonight and tomorrow. We'll continue on Thursday with this. Okay, L402.